All right, let's just jump right in. Our entire digital world, I mean, everything from multiplayer games to the global financial system, is built on a kind of quiet chaos. It's this problem we've all just accepted. The fact that basically no two computers on the planet actually agree on what time it is.
And this quote just nails it, right? It perfectly captures the problem of clock drift. Your computer thinks it's one specific nanosecond, the server it's talking to thinks it's another, and they spend all their processing power just trying to sync up and apologize for being out of step.
So, what's really going on here? Well, this isn't just a software bug. It's a hardware problem. It's physics. The tiny quartz crystals on a motherboard, the things that literally keep time, vibrate at different speeds depending on how hot they are. So our whole digital world is in this constant state of guessing what now actually is. But what if you could just get rid of the guessing? That's what a piece of software called the Atomic Kernel sets out to do.
Yeah, so instead of trying to force a bunch of physical clocks to agree with each other, this system builds its own time from the ground up, using nothing but pure math. And the whole thing starts with this core idea, something called a software crystal.
Now, unlike a real crystal, you can't hold this in your hand. It's an algorithm, and it doesn't compute like a normal program. It's not processing data or running logic. It just oscillates. It produces a perfect, immortal heartbeat that is mathematically guaranteed to be identical on any machine, anywhere, at any temperature, with zero drift. Absolutely none.
So, you're probably wondering, how on earth do you achieve that kind of perfection? What's the secret? Well, believe it or not, it all boils down to this one simple fraction, 1 divided by 73.
You see, when you calculate 1 divided by 73, the decimal it produces repeats itself in a perfect 8-step sequence. And that sequence becomes the pulse, the heartbeat of the entire system. Now, you might ask why 73? Well, it's the smallest prime number that gives you the exact 8-digit repeating sequence the system's architecture needs. The number wasn't picked out of a hat, it was mathematically inevitable. And because this is all pure math, it leads to this incredible efficiency. In a normal system, if you want to know what's happening at, say, tick 1 million, you have to simulate everything that happened before it. But here, you can just plug 1 million into the formula and get the answer instantly. It's what's known as O of 1 or constant time. It means you can literally jump to any moment in this universe's timeline in an instant.
Okay, so we've got this perfect clock. But a clock isn't much good without a universe for it to tick in. And the reality that this clock creates, well, it's one of the most brilliant and honestly counterintuitive ideas in this whole project.
You heard that right. This entire world has zero memory. It doesn't remember where you were a millisecond ago. Think of it like a kaleidoscope. The beautiful pattern you see isn't stored anywhere. It's just the result of light passing through colored glass at that exact angle, at that exact moment. It forgets the last pattern instantly because it's always just calculating the new one from scratch.
And this stateless approach creates a fundamentally more reliable world. So on the left, you've got our traditional digital worlds. They rely on memory, and that's where you get bugs. You know, like when your character in a video game glitches and gets stuck inside a wall. That happens because two parts of the system disagreed about its state. But over on the right, in the atomic kernel, there's no memory to disagree about. Glitching is mathematically impossible. You can't get stuck in a wall because the math that defines the wall and the math that defines you are absolute.
Okay, but this creates a huge new problem, doesn't it? If the universe has total amnesia every single frame, how does it prove who you are? How does it stop someone from just showing up and pretending to be you? How can there be any history or identity?
The answer is you move from the physics of the universe to its laws. And if you can't rely on something as flimsy as memory, you have to rely on something much, much stronger, pure cryptography.
Here's how it works. First, every object gets a system ID, or SID. That's a cryptographic signature that proves what it is, a person, a car, whatever. But the real magic is the object ID, or OID. Every tick, it creates a new OID by hashing the current time, the object's SID, and, this is the key part, the OID from the previous tick. The result is an unbreakable cryptographic chain that proves an object's entire history, all the way back to its creation. To impersonate someone, you'd have to fake that entire chain, which is just computationally impossible.
And based on that unforgeable identity, the system can enforce rules. The documentation explains it as 2 tiers of authority. You've got the normative layers, which are like the laws of gravity. They're just unbreakable facts about the universe. And then you have advisory layers. Think of those like a speed limit sign. The sign can tell you not to speed, but the sign itself can't physically stop your car. It's good advice, but it's mathematically blocked from ever changing the core reality.
It all comes together in this security principle called fail closed. You see, most systems today fail open. When they see data they don't understand, they try to be helpful and guess what to do, and that's exactly how they get hacked. The atomic kernel does the exact opposite. If it encounters anything ambiguous or invalid, it doesn't guess, it just pauses. The entire universe freezes instantly because preserving mathematical truth is more important than anything else.
So we have this perfect, self-governing mathematical universe. Incredible. But here comes the final boss battle. How do you prove that the perfect reality running on your machine is identical, bit for bit, to someone else's, running on a completely different computer, maybe even in a totally different programming language? And the bar the creators set for this is ridiculously high. They implemented this system in both Python, a super flexible and dynamic language, and Haskell, a language that's famously strict and mathematically pure. Forcing those two polar opposites to produce the exact same result, down to the last bit, is an insane test of determinism.
And the way they prove it is just so cool. They use these things called Aztec barcodes. Now, this isn't a link to a website. This isn't a QR code. The barcode is the data. The entire rulebook for this universe, the algorithms, the crypto keys, the whole shebang is compressed right into the pixels of this image.
I just love this quote from the source material because it really captures the sci-fi feeling of what's going on here. This system isn't asking you to trust that it works. It's handing you a portable, scannable, mathematical proof and saying, here, run it yourself. Prove me wrong.
So let's take a step back. What does this all add up to? We've gone from a simple fraction all the way to a verifiable, self-governing reality. This isn't just some clever coding trick. It could be a whole new foundation for how people and AIs can share a single, provably identical moment in time without ever needing a server to tell them what's true.
I mean, just think about the trip we've just been on. We started with an immortal software crystal, born from the simple math of 1 divided by 73. That perfect clock powers a world with no memory, which makes glitches literally impossible. Identity is guaranteed by an unforgeable cryptographic chain, and the entire living reality can be packed into a barcode and proven to be true.
But I have to leave you with this one last thing, this mind-bending detail I found buried deep in the system's documentation. Everything we've talked about so far is basically a perfect 2D world. But the author has already started laying out notes under the label conjecture/open for scaling it up.
And that really is the final question, isn't it? We've just seen how a set of simple, elegant, verifiable math can create a perfect shared reality for humans and AIs on a 2D plane. The principles work. So what happens when you scale it? What happens when you add another dimension and another? What are the actual limits of a universe built not on messy, chaotic physics, but on a perfect, immortal mathematical crystal? That's a pretty big thought to chew on.